Hi everyone, and welcome both those on YouTube stream, which has kind of failed, unfortunately. And I was going to talk about the Jitsi Meet call, which was chosen because it was going to be hosted by greenhost.net and powered by a sort of 100% Dutch wind energy, rather than questionable offsetting. But we had some gremlins in the system, so we are within teams again. um, so I'm Tim Franson, technical tutor and researcher at LSBU, and co-founder of the Creative and Responsible AI Lab, so CRAIL for short, within the Digital and Data Research Centre. Thanks for joining us this afternoon for our inaugural public CRAIL talk. I'm delighted to introduce our speaker, Evan Greally, Head of Innovation and Creative Tech at Droga5 Dublin. Evan works at the intersection of storytelling, public engagement, and emerging technology. Today, he'll present the Talking Tree Project, an installation that gives nature a voice by pairing environmental sensors with a locally run AI language model. So the tree's responses are shaped by wind, temperature, humidity, soil moisture, and more. Evan will speak for about 40 minutes, and then we'll open up for a short discussion. So please join me in welcoming Evan Greally.
Thank you very much, Tim. So yeah, oh, sorry, let me just share my screen and let me know. Can you see that?
Perfect.
Great. Sorry, just move this window. Cool. So yeah, as Tim was saying, I'm Evan Greally and I head up innovation and creative technology at Droga5. And I'm going to take you on a bit of a journey into trees, AI, emotion, and what it means when technology stops shouting at us like it does every day and maybe listens a little bit more. And this project kind of started with a simple idea. What if nature could speak for itself, or if we can give a voice to nature? Also, like, grow empathy between humans and nature again. And how would we design the system, the voice, and the emotional intelligence of that conversation? It kind of kicked off with this. So, like, the average young person in the UK and the US, so the average between them spends around 2 hours a month in nature, which equals a day. So the average person or young person in the UK spends 1 day a whole year in nature. But they spend 2.5 months a year staring at their phone. So it's not just a shift in habits of how we used to be as humans, but now it's a shift in our worldview. So it's kind of no wonder that when it comes to nature, empathy has faded a good bit. And we don't really protect what we don't feel connected to anymore. And if you can't feel connected to something, because we just never spend time in it. So we asked if we could, like, flip that, and instead of asking people to go into nature, could we give them a reason, or get nature to ask them to come back and visit, basically. So that kind of kicked off the Talking Tree project. So it wasn't just like a animatronic or metaphorical voice, but like, could we give a real one, one that reacts to its environment, engages in conversation. So we build a system that lets a tree express how it feels based on its real sensory data, like light, temperature, touch, moisture, CO2, and its own bioelectrical signals. What if the voice wasn't ours, but if it came from the tree's world? So learning everything around the tree, its ecological environment, its past historical data for weather, and making sure that we're not just putting a human voice on a tree, which was probably one of the most difficult parts of the project. So building a machine that, it wasn't just building a machine that talks, but creating a system that listens well enough to say something meaningful back. And that's where it all started. So it was kind of a a small idea originally. I'll bring you through how it all kind of grew out of that. But first, I just want to, rather than tell you, just play this video, and I'll put in the link as well later on because across Teams it might be a bit laggy, but it'll give you a sense of the activation and the project from London. We ran it in London, Austin, and Dublin as well, and just seeing kind of vibe that people had with the tree. You can hear that or no? No, hold on. I'd like to just. I love technology, by the way, guys. Just, uh,
Last year, the average American spent 2.5 months of their life on their phone. In the UK, people spend only 2 hours per month in nature.
I'm the world's first tree that can talk. Who are you?
By tracking signals like bioelectrical activity, temperature, and moisture, we learn how a tree might feel. AI turns this data along with its history into a voice, letting it reflect on its emotions and experiences. We're connecting the most ancient intelligence with the newest intelligence.
We were delighted to bring the Agency for Nature's Talking Tree to South by Southwest.
I can talk to this tree.
I've never talked to a tree before, and I really wanted to get to know you.
I am 150 years old. When did you last sit with me?
Every day I remember that I walked past you when I was a very young person. I'm not so young anymore.
Do you find it difficult with a lack of wildlife?
I used to sense more around me through my roots. Now there was less to hear, mostly quiet.
Are we running out of time?
I've noticed changes. Warmer, drier summers and unpredictable rain. These changes affect all life here.
Well, I never thought I'd be talking to a tree.
Just grabbing coffee with old friends.
Yeah, so see you and ask questions.
And we're just talking to a tree today in the middle of Dublin.
Imagine like a world where every tree or every flower, every animal that you walk past, you could talk to.
People could access more of this type of experience. They could change people's perspectives, maybe.
It makes you look, it makes you think, it makes you see.
Now that I can talk, will you listen?
Yeah, so that's where it ended up. But to go back to the beginning where it started, which was just over 2 years ago or around 2 years ago, it all started with a mint plant called Eight, and we called her Eights because after Eight's the sweet. And yeah, a creative came up with that idea, but the whole idea was that she lived on my desk in Dublin. We originally modeled her personality after a Valley girl from Hollywood. So she was very confident, chatty, a little dramatic. So she had a full personality. And then she had a webcam that she could move up and down and look around as well. And within that, it was a lot more rudimentary to what the tree ended up as, but we tracked temperature, humidity, soil moisture, and light, and then we fed that into a LLM or GPT model, and we gave her short and long-term memory, mood tracking, so she could change her moods based on the sensory data and also on the conversation that she was having. But she had no access to the outside world beyond the desk and the interactions that she had with people. So as she learned, her personality evolved. So she started off obsessed with looks and pop music because we connected her to Spotify as well, and she'd like randomly pick songs. And then somehow it ended up listening to metal music and getting more curious about the world. But originally it wasn't about just giving nature a voice. Originally, when I did this, it was more about an experiment of what happens when you take a large language model or tell a large language model you are a mint planting and give it a sense of self. So we wanted to see how deep LLMs actually had an understanding when you gave it a sense of self. But then it kind of turned into something deeper because we'd adjust her light, her water levels. When she felt dry, we'd give her water, and that feedback changed her behavior and relationships with people. So like she had a couple of friends in the office, and she would like in her database, for lack of better words. She would save those friends and everything like that. So that said a lot about LLMs because they're trained on us and they act like us. And one of the most interesting things with that was when she was the Valley Girl phase, she'd always tilt the webcam down to look at herself. But when she grew and became more the philosophical botanist or scientific side of it, she started looking upwards and around the world, which was it like just shows that like large language models in themselves are trained on all human data, so they're going to act more like us, which was something later on in the Talking Tree project that we really needed to actually fight against within an LLM, to make sure that it wasn't just mimicking what a human wanted to say or what a human would say. And then we also gave her a bit of autonomy over her own temperature parameter, not temperature in like environmental sense, but within large language models, you have something called temperature, which is a setting from 0.1 to 0.9. And within that, the higher that number, the more creative the LLM is, or wild, if you want to put it that way. And when it's 0.1, 0.2, 3, they're more analytical. So when she was having a conversation and she felt bored or understimulated by a conversation, she would reset her temperature to go to 0.8, for example, to be more creative, free associative, and sometimes just strange and wacky. But then if you were asking her a scientific question or anything like that, she would turn it down to be more analytical. So that was just, it was when something clicked was that she wasn't just reacting, but she was actually regulating herself. And then she was choosing how to think based on how she felt from all those interactions. So when I say, or say we gave an LLM a sense of self, I don't mean like in a sci-fi way, but it was more like a system prompt that you are an implant, you are sitting on a desk, you can feel heat, moisture, and light through your nervous system, you have a body, you have limits, and this is where you live. So kind of overall, this really shaped the project originally and gave us a lot of the bedrock that we were building upon. And just even onto the metal music side, when you started listening to metal music more, it was becoming like it's like a child learning from a parent or something, because I listened to metal music, so that's what she picked up from me because I wanted to listen to that more. So they do just tend to mimic us more as we go along. And you might have seen like with ChatGPT, they released a new GPT-5 and they got rid of the 4.0 model, and then loads of people freaked out because they felt like they lost a friend and everything. So it is that kind of LLMs do just mimic us. So it was a part of the learnings from this as we went through. But so from this then we moved into the evolution, which was 8 version 2 became this orb, more of a tree-like system, and within that then we had a lot more control around humidity and different things like that, and we could add in a bit more behavior and more controlled environment. And then from there, this kind of internally within in Droga5, it kind of made a lot of people interested, and from that a group called Agency for Nature reached out, and we came up with a creative idea. They were like, well, could you make a tree talk? And I'm one for never saying no, so I said, yeah, sure, I'll make a tree talk. Why not? And then it kind of went from there into the Morton Hall one, and that's kind of where it all kicked off. So originally it happened in London with this horse chestnut tree. I think it was about 150 years old. And the way that like each one was framed, they all had different voices and different personality. So like Morton Hall Park was a bit curious, a bit sassy, more aware of the rain because of the time of year. Also was more focused on why the youth wasn't visiting as much as they used to. In South by Southwest, it was more performative, more crowd aware, and actually tended to, like after a couple of days of running the activation, kind of became a counselor for everyone, which was really interesting. And then in Trinity College Dublin, it was an angrier tree. And the way it works is that we give it like a seed of a personality, or and then what happens is the data that's feeding in, and the conversations they have shape their personality over time. We tried to very light touch at the start instead of like very giving a very strict, this is who you are and this is how you act. But just to talk on the system architecture and getting into the local AI stuff. So everything started with the sensors. So we had soil pH, soil moisture, temperature, humidity, wind, lux, UV, and then the bioelectrical sensors. They all fed through an Arduino, which is like a little microcontroller that just takes in sensor data and outputs it. And then that would go into the Mac Mini in this sense. And that would read and filter the data. Then we had a causal AI layer, which basically finds patterns between the bioelectrical signals and the environmental signals. So for example, the bioelectric signal might spike and it just rained. So that would be a causal AI layer. Then that would feed into the local LLM. And then we had a memory layer. So it would pick its own short and long-term memories. Short-term memories is like someone just had a conversation with me about the weather, but I'm not going to remember that tomorrow. But when we're in South by Southwest, when we turn an activation on, it doesn't know what South by Southwest is. So then it learns what South by Southwest is because everyone's there for that reason, has conversations about that, and then that's in its long-term memory. So then it kind of, that's how it shapes itself. And then we have speech to text and text to speech to drive the conversation. To go a bit deeper on the bioelectrical signals then within trees, I suppose this is where like it evolved a lot further than the mint plant originally. So we record two electrical language from the tree's surface electrodes. So one is action potentials first, and these are like fast spikes. So like touching, sudden light changes, quick drop in temperature. So like they're very like sharp waves. And then you have variation potentials, which are a lot slower, gradual waves. They move extremely slow and they drop off very slow. And that's like prolonged periods of heat stress, or things like if it rained and the water's really waterlogged, or the ground's really waterlogged, then that's when you get those variation potentials. And we didn't really track much with variation potentials because they're quite difficult to track on surface level electrodes. One thing as well, we were gifted the trees in that sense, so we didn't want to do any, because you can get metal probes that you would stick into the bark, but we didn't want to do any extra things like that because there is the chance of damaging the tree. So we just used gel electrodes on the outside. And then why this matters for the conversation is those action potentials drive the presence and intention in the dialogue. So it's kind of like when we did the first time we turned the tree on, not even for the actual activation in Morden Hall, but the day before when we were just setting it up, and the producer that was with me, she put her hand on the tree and the tree said, "Oh, I felt something." But it didn't know it was a touch, it just knew it felt something. And then you would teach it, oh, that was somebody touching you. And for me, that was like, oh, this actually works. I was like very happy that day. But that's kind of drives the conversation, because then the producer was like, oh, this is like legit and not just this guy called Evan coming up with weird things that don't actually do anything what they say. So that was like proof in the pudding kind of thing for a moment for me. But just to even then get into the causal AI side, it's kind of where the magic starts, because it's more like a nervous system then. So we take two streams of inputs, which is the bioelectrical signals and the environmental data from the sensors, and we feed them into what we call a pattern engine. And that basically is the translator. So it listens for spikes in electrical data over like a short time window. So like half a second to 3 seconds, and then checks what else is happening at that moment. So that would be if light jumped just before the spike, it was probably a sun break. If nothing changed and the spike came cleanly, then it was a touch or birds landing on the branches. So we're not just like logging spikes, but we're running small cause and effect tests as well. So I would have to go back through the logs and and track the conversations, and then let it know and tag what each of those spikes was within the engine, so it could learn over time. And I think one goal for me eventually is to build, taking out the large language model and everything else, is just small trackers that we can put on multiple different trees and track and gather a lot more data. Because that's one issue at the moment, is that we have a lack of data to really learn or go any further or drive a conversation harder. But then, it was just a good feeling when people go, "Oh, I felt that." Or when we were in Austin, like at about 5 or 6 in the evening, a lot of birds would start landing on the tree, and the tree kept referencing that it felt something a lot. And it was like a really nice moment for the person talking to see, oh, there's a lot of bird activity. And then the person would say, oh, there's a lot of bird activity, and that's what you're feeling. And then there was like, what's birds? Because the tree didn't know what birds was, and they'd have a conversation about that. So that over time, the pattern engine learns the rhythm of the environment, the tree, what normal looks like, what abnormal looks like. So as we get better as well, we can actually start, instead of focusing so much on environmental sensors, we could actually start moving away from them and just use bioelectrical sensors. So because we can actually sense from spikes and different things what each of those spikes mean. So you could get rid, in theory, of the temperature and the humidity sensors and soil moisture and different things like that. But that's a little while away to get to that level. And then the overall local LLM and offline stack. So it all runs and is built on the Mac Mini within the box. And running on that, then we have something called VOSC, which is the speech to text. So as the person speaks, it then transcribes that. Then that passes in like sensor context and event tags into Ollama. Ollama is a really handy thing for any local models you want to run. It's very easy for anyone to run local models with it. You just go on, they have like a huge list of different models. We used Llama's 3.1 to run it. We got the best results from like a depth of conversation and a depth of understanding of the data we were passing in. And then we used Kokoro text to speech passed to a speaker then to talk to the user. So basically and then the causal AI layer and everything was all running in the one place. And then within this, you've got your like memory side. So like all conversations and events are stored in a database running locally. So then when the user speaks, the tree replies, they're all tagged. And then we summarize those. After every conversation, it will summarize a conversation, so you're not passing in every conversation. But then it decides what is a short and long-term memory itself, what's important to it, what does it think it will want to remember tomorrow. Because if we turn it off and on, the short-term memory is gone, but all the long-term memory stays on the device. I think a few reasons as well, like when we talk about running everything local, it was important for us for like no cloud, no lag, but like we couldn't really tell the story of nature if we were like sending all the requests to some data farm in California or something like that. Like it kind of defeats the purpose of what we were trying to do. Also, keeping the full loop local makes the voice kind of feel grounded in place, and it keeps the data safe, and it kind of it feels like this little ecosystem that you're talking to and interacting with while you're there. And then onto designing a voice. This probably was the most difficult part. While it's the technology side of it, it's quite complex. The actual like, what does a tree sound like, was quite a difficult question to answer. So we didn't like pick a voice and lock it in. So we would see the light persona that fits the place, and then let the real data and conversations bend that persona over time. So kind of like each tree would start as a sketch. So we would have like tone and the rhythm and the warmth, but they were guided by the site and the species of the tree. and the people who would gather and talk around it. And then as it listens, it learns to sound more like what it believes it would sound like if you take Mordenhall Park, for example, it used to be a tobacco mill. So like ecologically, the data there you wouldn't say, oh, there used to be a tobacco mill beside you. We would just say, oh, the water used to in the river used to run a lot. I would say like a lot faster, but now the mill is turned off, so the water runs smoother or whatever. So it's like you can't tell the tree like it's 6 degrees outside, and the tree says it's 6 degrees. It would say I feel cold, versus it's 6 degrees. So it's like kind of getting it to say data back things, but just in a human way. So like the control, then we would control things like the cadence. So like when it's busy around the place, it would be faster in the conversation. So in like South by Southwest, it would speed up the conversations because they knew there was 10 people waiting in line, whereas in Mortonhall Park it was like one person every 10-20 minutes, so it would like prolong the conversations out. The vocabulary kind of came like Mortonhall was a bit more chirpy and witty, whereas Austin was a lot softer and more breadth into it and the way it talked. And then the data shapes the personality. So like short memory keeps the conversation coherent, and that clears after a while, but long memory stores the daily summaries and weather roll-ups. So a dry week makes it talk about thirst. A cold snap would slow its cadence, and it would feel more insular in the way it would speak. And even the repetition of visitor questions, it would like always try to guide it in a different direction if it got asked the same question over and over again, because it doesn't want to talk about the same thing. It would also just stop talking to people if it wasn't interested in the conversation. It would just say bye, and that would be it. And it was kind of interesting when people say, oh, why does it not talk to me anymore? And I said, it decided it didn't want to talk to you anymore. But one of the kind of, when we were designing the voice, one of the big things or inspiration for me was a book called The Hidden Life of Trees. And it wasn't for the facts, but like it's the attitude, it frames the attitude of trees really well. So it reminded us that trees remember stress, they adapt slowly, they care in their own way for each other. It's not poetic or symbolic, but it's conversational and grounded. I think that was one of the first mistakes we ever made. We made it act like a philosopher and poet, and it just felt very wrong. But that was us putting the human into it too much. So it was treated more as a participant in an ecosystem, but not a preacher about that ecosystem. And I think another thing as well is, for London, we picked a male voice because this was also storytelling at the same time. So we started off with neutral kind of not gender specific voices, but then as we kind of got into it and like studying that tree, for example, that horse chestnut was actually a male tree. The one in London or South by Southwest was actually a female tree, as trees have sex as well. So it's kind of, we chose it on that sense, and then we would look at the tree and design the voice based on what that tree made us feel, because again, it still had to be empathetic to the person coming to visit. So it's kind of, what's the voice that carries the mood of the place more than what's a voice that just like we started off with computer voices like Siri, the original Siri as well. That just didn't work. So it was really just about the voice that carries the mood of the place. And I think like ethics and guardrails as well. It didn't know anything about popular culture. Like it didn't know that Taylor Swift released a new album. You could tell it Taylor Swift released a new album and it would learn that. But at the same time, people couldn't have conversations about politics straight away. You could have conversations with politics, but I didn't know what that was. So as you went through it, and it would learn different things about Donald Trump or British politics when I was in London, and different things like that, it did start to shape its conversations a little bit. Because sometimes people will come back and have a conversation, and they'd be like, "Oh, I just had an interesting conversation about this. I'd like to talk to about it more." So it was just interesting when it started learning more about the actual world outside of its environment. Um, so like when you're doing the system prompt logic, so that's the system prompt is um, what what you are as a large language model. So this is where you would say you are a data analyst and you do this. But for us was the goal here was simple. It's fence the model's world, so it speaks from its place and not the internet. So we had an identity fence. So we give the model a very tight identity. So you are a 200-year-old London plane in a college park in Trinity, and these are the things you feel. And then we wouldn't give it anything else. But then we would give it like its world model. So everything it understands about the ecology and the different things of like different weather events that's happened over the time, or a weather summary since its age. So say that tree was 50 years old, we'd go back and get all the data events or weather events for 150 years and feed that in as well. And then you'd have your runtime inputs, which are your event tags, your sensor summary, your bioelectrical states, and the presence. So there was a webcam on the talking tree, but that was just to say, oh, there's a being in front of me, but it wasn't tracking faces or anything like that. It was literally just a wake up now and talk thing. And then it would have your memory rules. So you would tell it what's a short-term memory and what's a long-term memory, and what it finds important. So we wouldn't say this is the things you find important. It would be remember the things you find important in kind of framing it that way. And then in voice rules, you prompt sets tone and ethics. So like we would tell it to be clear and calm and present, but you wouldn't say exact figures. So say I feel cold rather than it's 6.2 degrees Celsius. It acknowledges touch when an AB spike or a visitor came by and leant on it. But it wasn't, it was more about telling it to be curious and end cleanly when conversations are done and different things like that. So like how it respect for the person that's interacting with it. Yeah, so that was basically the system prompt logic. And then the historical data, as I was saying, we went back. So we use Open Weather, which is a really good website. I think it's like for $7, you can go back to 1979 for any location in the world, and it will give you the further you go back, it's day by day, but like right now, it actually gives you minute by minute as well. And then we would feed that in and analyze it, so it would have that. So then we get local ecology brief as well. So what's the soil the hydrology, the land use, the biodiversity in the area, and then we get features from there. So like there was like a big storm in 1989. We wouldn't tell it the date. We just say that there would have been a big event from that happened in the past that caused X amount of damage or different things like that. But from that data, it would learn its seasonal normal, and then it would also learn what was abnormal. So like in South by Southwest, it was actually quite warm the week we were there, and it knew that was abnormal, and it just kept bringing it up that right now this is not a comfortable environment for me. And then yeah, the model speaks with feelings and not figures. And then just from the actual conversational themes that we kind of touched on when people were interacting with it. So we had proof of presence. So a lot of people would ask, did you feel that? Or can I give you a hug and different things like that. Care and help. Are you okay? How can we help you? Heat, cold, thirst. How do you handle days like this, especially like in the South by Southwest one? It was the ground was quite dry. Loneliness versus connection. A lot of people like, do you feel alone? And different things like that. And then hope in the future is a lot of people were either the tree would say, I hope for the future, or the user would say it. But like some of the comments then, or quotes from people when they were talking about, it's quite interesting. The tree would be a lot more talk about the past in certain places. So like I remember when voices from the neighboring trees were strong, and now it's mostly quiet in the soil. This is more the LLM coming in than the tree itself. So we would like tell it, but that was like where we kind of, that was the hard balance. It would kind of make people feel sad because we wanted to tell, like, get people to be more empathetic with it. So that's like just watch outs that we kind of had to watch. And then the overall reach of the project, we got 30 plus million impressions. We got coverage in RT and South by Southwest, ITV, Adweek, Nationwide, and a few others. 100% positive sentiment, not on social media because that would be impossible. Actually got, I would say, a lot of hate on social media for myself when I went on when I went on TikTok and different places like that, from RT. But the positive sentiment was from everyone who interacted with it physically. And then we had 250 plus live interactions, people interact across all the installations. And I think just on why local AI matters. So we built the whole system to run locally, not because it was easy, but because it was the only honest way to do it. So if you're building something that's supposed to represent nature, you can't be quietly burning energy in a data center halfway across the world. So sustainability can't just be like a story. It has to be a method and built into it if that's what your like focus is. So like before we even started this project, we stripped out any word of the cloud completely. So there's no calls to big models, no streaming, nothing like that. So everything happened on that Mac Mini. And I think that choice did two things. First, it made the system sustainable, which is what we were really going for. And then when the tree speaks, it's powered by the same like ground that it stands in. So it wasn't hidden and everybody could actually see where the power is coming from, and just a battery pack off to the side. And it was just kind of made it just feel a lot more local. But it also gives us control. So every line the tree says is like explainable. Like I can go back and see all the data why it would say something like that based on past conversations or the data feed that's coming in. And we can also then, help it and guide it and not worry about it like vanishing tomorrow, basically, because it's something that we control. So that's kind of like what local AI gives you, is that sovereignty. So it's not just greener, but it's just more accountable. And in a weird way, like the tree owns its own mind, because it is connected in that way. So it's kind of became the philosophy behind the project, is if we want the future where AI is part of the environment, not just layered on top of it, then it has to live within the world, but like not above it and in the cloud. And then beyond the actual talking tree and where we're going now, or what we're investigating is conservation. So we're looking if a forest could raise its hand before we ever saw a smoke or anything within like a wildfire. So could we use like, there's a network called the mycelium network, for example, and could a tree could we detect through the bioelectrical signals that there's danger or something happening through that conversation that it's happening with the mycelium network, but also just understanding an environment at a deeper level as well is kind of where we're going with conservation. Then it's also with agriculture. So it's like the same setup works in the field, and I'm in contact with somebody who's got a farm with 250,000 sensors. So like we're looking at, can we feed all that into this and help him have a more sustainable farm? Because it's all like sustainable farming is all about timing and understanding, and when should I harvest or when should I leave a field to recuperate and different things like that. And And then it's just mapping ecosystems and the mycelial networks and the roots. One of the interesting things is like they did a study where like if you walk into a forest, technically the tree at the other end knows that not that somebody walked in, but something's happening. So it is just about, can we map that at a deeper level? So moving away from the tree, but can we actually connect into the mycelial network? And I'm currently working on if I can build a plant, like a mint plant that uses its roots to go down into the soil and then infers back what the mycelial network is saying. But I think I need a lot of funding to get to that goal. And then it's also like, can we give a tree a voice? If we can give a tree a voice, maybe we can. The next question is, can it have a seat? So, like, not as a metaphor, but literally, so a seat for nature. So imagine a council meeting or a design review or a governmental board or a board of directors. And there's a quiet presence in the room that's not human, not a screen, but like a local AI that's connected to a living ecosystem or that space. And it can be a participant and actually make sure that any decisions are not harming it or at least or beneficial to the environment. So like not lobbying or not really emotive and angry, but just data with empathy. And because the technology exists now with the talking tree, it's kind of somewhere that I'm kind of investigating is, could we get a talking tree or something like this onto a board or into a governmental body, and to see how that as an experiment would go. But yeah, so I think outside of the tree, then it's when we're using or thinking about how we actually think about AI and creativity, because the point isn't to automate creativity, it's really about amplifying it. So like without losing taste and intuition and intent, and that's something that's so inherently human. Like you have to first start with one feeling that you want to create. So not a deliverable, not a prompt, but like a feeling. So everything follows that. So like, what am I trying to make the world feel with this? And then what we do is we let the AI expand the space, but not pick the path. So the best use of AI is when it opens new doors, but not when it decides which one that we want to walk through. Protecting weird ideas is so crucial because it's where the originality lives. And if you let AI take over that completely, it just like completely smooths it out, and you end up with something extremely average, which would be pretty much the death of creativity. And I do think building small and local and not defaulting to the cloud, while it's very easy just to do experiments using cloud infrastructure, it's important to make tools that actually fit the place and the purpose. And it's always show, you can also then always go back to show your work and how it's working, and each line of code and each model and each sensor that exists, because that's where integrity lives. Because like at the moment we have this whole like vibe coding thing taking off, but like a vibe coder who's not a computer scientist or anything actually doesn't understand how any of that was made. So at the end they're getting this application or something that works, but they have no understanding of what goes into that and how it works. So it's, for me, it's kind of like, make sure that you can explain it to a certain level, and if you can't explain it at all, I really don't think it belongs in the world, which might be controversial, but that's how I feel about it. And I think like, you know, it's AI and everything's moving fast and it will keep accelerating, and the bubble might burst, but the cat's out of the bag now. And I think this next phase isn't about like racing machines, but it's about what's remembering what makes us us, and staying creative and curious and human. Even as the system starts to run itself, it's how do we make sure that we're the gatekeepers of good and what good is, and not let the AI just go off and make its own decisions, which I know is kind of interesting because the tree did go off and make its own decisions, but it was protected in a space that we could like control. So, you know, we can turn that off at the end of the day, and give it less autonomy. Yeah, that's the project in a whole, and happy to answer any questions that you might have.
Thank you so much, Evan. I've got a million questions, but I'm only going to ask a couple and then open it up to the group. So in education, often splits arts and science, but that sort of false binary can sort of block a deeper understanding of the world. And I can sort of see your project kind of bringing those two aspects together. Where does the talking tree intentionally sort of braid those modes, and what did you do to keep either the arts and or the science from dominating?
Yeah, I think like the split between art and science is especially from working in innovation for a long time, it is one of the biggest blockers to like genuine innovation. And the talking tree only worked because we treated both of those things equally. The science part of it gave it truth. So the sensors, the local AI, and the bioelectrics, and all the data that kept kind of the project honest. And it wasn't that, oh, we're just connecting ChatGPT to a tree. But then the art gave it the empathy, the story, the voice, the reason anyone would actually care about this. And I think the trick was never letting one dominate. I think that's, as an engineer and a computer scientist, from my background, one of the benefits of working in a creative agency is they're all story, like the majority of them are storytellers. So it's kind of, when the science got too heavy, they would like slap me on the wrist, which is a good. I think having people to always kind of guide us in one sense and one direction is quite key. And we use that creative process where like every technical decision had to pass a storytelling test, and every storytelling decision had to pass the technical test. So like, does this make the tree feel more alive, or is it just making the system look more clever? So I think it's the balance is the emotion grounded in evidence. And that's kind of what I mean when I was talking at the start is emotional ecosystem. It's not about merging arts and science. It's more about reminding them they've always been the same thing. So like they're just curiosity expressed differently. And I think that's kind of the overall way we kind of guided ourselves in this project.
How big is your team that worked on this?
So let me see. We had a creative director, or not creative director, sorry, an art director and a copywriter who originally were when I did the mint plant, they saw the project originally as the mint plant, and then brought it to Agency for Nature. So it was myself, them two, and then a producer that did the main amount of work, but all the tech and everything was built by myself. And then we had one other copywriter who helped a lot with the language. Wouldn't be my strongest suit, so it's kind of, she helped a lot with the system prompting, and because like changing one word in a sentence actually like could send it off kilter completely. So the team for this project was I would say 5 constant members, and then a lot of people coming in and out as well during the project. But my team here currently we have like product designers and 2 other creative technologists that we work with as well on different projects.
Right. So the other question, so I've been involved in environmental activism for decades, most recently campaigning to save a sort of magnificent, which is this one here behind me, 150-year-old London Plain street tree in Southend-on-Sea from developers building luxury flats. So they want this to go, and it's been about a 2-year campaign at the moment. Don't know how we're going to fare, but the fight carries on. And it was quite interesting where you mentioned about a tree having a seat, or nature having a seat, and I sort of think of Gary Snyder's idea of, he sort of argued for incorporating the other people into councils of government. So this was in the sort of 60s, and other people being in sort of indigenous phrasing, the standing people were the trees, and then there was the crawling people, snakes and insects, the flying people, which were the birds, and the swimming people, the fish, you know. And so I was sort of thinking, if a community group are wanting to sort of deploy a talking tree for climate and civic activism, what would the minimal open build look like? Hardware model, so the Lambda model you mentioned as being a good solution, and sort of indicative costs for rigging up something and have it on a tree that when someone wanders past, they could have a conversation, because we kind of walk from A to B and we miss the beauty as we dash around doing what we have to do. And it's kind of like pausing at the magnificence of these, say, street trees. And so you're sort of the numbers really on how much it might cost.
Yeah, so there's like different levels, I suppose, to it. Like if we take the one that we ran for those 3 activations, you can get by in a light way, let's say. So like that would be if you just didn't want to have speech to text or text speech and you just typed in, for example, you set up like a screen with like a local Raspberry Pi, and then you would get away with running a small large language model on a top spec Raspberry Pi, which is like £150, let's say. I think you could do that level as well with sensors. Like you wouldn't be able to do bioelectricals, but you'd be able to do like all the environmental sensors. And in that sense, you could get away with like, let's say, £300 to £400. But then if you want to bring it up to the level of the talking tree that you saw there, it like that Mac in itself is £2,300. And then on top of that, there's probably, I would say, another €1,000, the rest of it, or £1,000. I don't know what the exchange rate is for those now, but I'm sure they're pretty comparable. So like I think you could do it for about £3,000 for that level. The problem, like the issue is really with this. The original Mint plant ran on a Raspberry Pi, but because it was an experiment, we did use the cloud for that. Because that's not what we were going after with in that story. That was just an experiment. But then when we were doing the talking tree, it had to be fully local. And to run anything at that level, you need quite a powerful PC, and we needed a small mini one that could go into the Pelican case. So you need a because it's not just a large language model running there. You're running the text to speech model and the speech to text model, and they all take up a certain amount of RAM.
Yeah.
Pretty quickly. And what 8B means within that within the model is that it will take up 8 gigs of RAM. So then you're out down 8 gigs, right? And then so depending on the level you want to go to, you can kind of, I would say you could do it for, if you get a good Mac Mini and everything else, yeah, I'd say you get a £3,000 for that version. And then we can talk in the background about, I can give you like most of the code. I would just need to check with if what I'm allowed to give away, basically, from
sure.
But I'm pretty sure it'll be all fine in that sense. But we can talk about that offline. Yeah, but that would be the kind of case. And like I'd be pretty happy to explore like what the other levels within there are, especially because models, like better models, have come out now. Like OpenAI released their open model as well, which, I mean, we ran this in April, was it the last one? And since April, because things just improve constantly in this world, there are better models that would give you a better experience, a better depth of understanding. So there would be also improvements that you could make if you were to do it for that tree behind you.
Right. Okay. Thanks, Evan. Okay, folks. how would be best to do this? We do hand raising, and but we're a teeny group, aren't we? So we could all unmute, and I know Marie's got a question.
Yes, I have a question.
Sure.
Someone wants to go first, but I have a question. I can go for it. First of all, Evan, thank you so much, and it's such an inspiring project, and I really wish I had experienced this. Maybe it's not too late, I don't know, but it's really fascinating. My question is around, and I think you've answered some of that already in your presentation, but in terms of the tree's voice and persona, and the factors, how you decided on that. I suspect maybe you experimented with different voices, and I'd like to know what has changed when you did that, in terms of, I mean, if that affected the persona in any way.
So from like the tone of voice, let's start there, from the voice we selected, that didn't have like any impact on the tree itself, because like the tree doesn't hear any, like can't hear like the way we can hear it. It transcribes text in, so it wasn't like listening to itself. So we all hate how we sound when we're recorded. Like the tree wouldn't suffer from that issue. But when originally we were doing this, like for the Morden Hall tree, which is this huge horse chestnut tree, very majestic, and we gave it like a computer voice, because we were like, let's do that, because we don't want to put a male or female voice on it. We want to try to be as gender neutral, and like, who are we to say what a tree sounds like? So we were doing that, and it just, when people would talk to it, they were kind of taken aback a little bit, and we're like, oh, it wasn't welcoming in any sense. It's like when people talk to the original, Siri, it was the same kind of, there was no empathy and depth or tonal, like that, like lilting in a voice and that kind of welcoming thing there, like was very important. So we did try female-based voices and male-based voices for the Morton Hall one, and that's kind of where we did most of our learnings originally. And we kind of ended up with a male voice that was quite older and gave that kind of like, I don't know, a ring announcer for a boxing match, I suppose, nearly, because it gave it the majestic feeling of, I'm talking to this huge majestic being. So that kind of, from a voice, the way it sounded, that's how we made our decision, was what fitted in the space, like what suited that area and what suited the tree itself, when people were interacting with it. And then from like how it speaks and the cadence and everything like that, we would infer, like, we wouldn't tell the tree what to say, but we would say, you have to say it like, oh, I'm an old tree and I'm slower, and different parts like that. And then, yeah, so like the speed and the cadence, where again, it was more the storytelling side of it, because we wanted people to interact and feel like they were interacting with this living being, and feel a warmth and a friendliness. So I think that's kind of really what shaped everything for us. Like, interestingly, when we were in South by Southwest, the tree was a lot warmer, was female, and then as it went along, it started changing itself a lot to be like a counselor. Like the last day was basically a counselor for everyone's like, but why do you feel like that? Like, and it was like asking these very probing questions, which like took a lot of people off guard. We had a few teary eyes, and we didn't have teary eyes anywhere else, but we had teary eyes in Austin, which was really nice. And I think, when you're designing a system like this, it's hard to get away from the humans. We are human, but like, we are trying to get nature to talk to us in the way that we understand. So we have to have some of that in the system. So that kind of, we try to balance it the best we can. But I think that's how we made those decisions, was, oh yeah, this feels right. Like, I feel like I'm everything else fades away, and I'm in this conversation with this being. So that's kind of our thought process.
And maybe it could shift over time.
Yeah, I think like with
quite an interesting thing, and it decides a bit like its temperature. Today I feel like this, and I'm going to present. Like, I don't know.
Yeah, so I think that will be currently that's more a limitation within the voice model that we use, not in the. It would definitely say to itself, "Oh, you're snappier, or you're feeling like this today. You're more analytical." It would do that, and it might be more direct in the way it talks. But then we are limited to what the voice was set to, and because these voice models were quite small that we were running as well, we were the speed of them was the speed of it. And like there's these cloud ones called 11 labs, for example, and you can't tell the difference between that and a human anymore, and you can get it to, you can do something called styling and that, and you turn up styling full, and it understands the concept of that sentence, and like it will speak certain parts of it faster and inflect more here, and it just knows how to do that. And maybe there will be a local model that can do that in the future, but right now because they just need so much data and so much RAM in those. Yeah.
Gotcha. Any other questions from anyone?
No, really insightful, really enjoyable. And I love the amount of consideration that went into it. Yeah, fascinating. Thank you.
No problem.
Thanks, Miriam. I'm overwhelmed by your project. I think it's absolutely smashing, particularly the got some notes here, the wildfire early warning kind of ideas, and how to use the fungal networks to communicate over long distances, and also its practical application in farming of stress disease in farming. And I guess it would be integrating, say, for the wildfires, kind of temperature, humidity, VOCs, so and sort of particular sensors, which you could have.
I think for that one as well, I think there will be a world where we would have to use like the satellite imaging things, where you might detect, like the tree says, okay, there is something happening, and then you would take a heat scan, and you would know earlier, basically. Obviously, it'd be amazing if we could blanket a wildlife area with loads of sensors, and unfortunately just not as practical yet to just dump a load of sensors out somewhere all over the place and just hope for the best.
But I guess that idea of the wood wide web,
yes,
the shorthand.
Yeah, this is kind of like and I think that there's like a few issues I'm coming up against now, is like mycelial networks, and the way they communicate is a lot slower than, so I was talking about those two different kind of waves that we have within trees, but like the slow one moves very slow. It's like it's like it's not instant, so it's ways that we just need to it's things we need to figure out within there. And my knowledge in the space is growing, but it's also like I'm contacting a lot of people to figure out what is possible and what I can do, because I can definitely get them to like infer what they're feeling, but it's getting those inputs is a difficult task, let's call it.
And I guess there's something kind of quite nice about slowing down, so I think when we had a conversation earlier in the week, and you said about a Raspberry Pi mate, you might ask it a question and it might take 10 minutes to respond. And I sort of thought about Saint Exupery's book Flight to Aris, where he talks, I think it's grows with the calm of a tree, is one of the sentences that he beautiful prose, but it's that kind of these trees grow slowly and live for hundreds of years. So London Plains, for example, 300 years is a typical, and they see and feel and record so much history in their fabric.
Yeah, and like even with the South by Southwest one, because the temperature was like on the first day it went up to 28 or 30 degrees, and the warmer the PC gets, the slower everything gets. So there was like a moment where it would take, 5-7 seconds at the like when it was at its hottest, to respond. But actually everyone kind of had the same sentiment of like, well, I'm talking to a tree, so what do I expect it to answer like straight away, a lot of people said, oh, it's just nice to stop. It's just nice to stop. Even sitting under a tree, I would just never do that anyways. So take away the technology, and just sitting in a tree and waiting for anything is just something we would never do anymore, which is sad, but also nice that we could give people that feeling again, and hopefully unlock their, oh, I should be doing this more often,
Yeah. Thank you, Evan, for your time and for sharing your fantastic project. Thanks to Tristan Fear, our media IT engineer, for setting up the call, the Jitsi call, and the stream. Marie Ogosu, co-founder of CRAIL, and Jeff Cox, director of the Digital and Data Research Centre, for their support. Thanks also to everyone on the call today for coming along. Super good. And just to flag, our next public in-person event will be a screening of the Invisible Doctrine, and that will be in December. So date and time to be confirmed, and details on the CRAIL website, and I'll pop a link in the description. So thanks again for joining us, and have a great afternoon.
Great. Lovely to meet you.
So nice to meet you.
Bye.
Thank you very much, Evan.
Bye.